Good evening. Could I welcome everybody tonight, both here and overflow in the upper gallery over there. It's very nice to see so many people here, not in the slightest bit surprising, because the subject is a very interesting and a very important one, and the two people we have speaking are both very much expert on the subject. The idea is, as I'm sure you know, it's a discussion meeting, which means two people speaking, and I'll come on to that in a moment, and then a discussion, as it were, with them as the two panelists, which in essence is questions from the floor and questions on the whole rather than another lecture. And then I'll throw those to the panelists and we can have a good discussion. It really is very pleasant indeed to have this topic and to have the two people who are going to speak. And they are, in turn, Lord Turner, Adair Turner, who's going to talk about reducing greenhouse gas emissions, science, technology, economics, and ethics. And very briefly, I'm sure most of you here know who Lord Turner is and a great deal about what he's done. But Adair Turner was educated in Scotland, partly in Perthshire, before going to Caius College in Cambridge. He was a college supervisor, in other words, a tutor, after he graduated, when he taught part-time in addition to his own business career. He was a visiting professor at the LSE, Cass Business School, so he's got a huge amount of academic experience. And he's also got a great deal of business experience and government experience. He was with McKinsey's, built up their practice in Eastern Europe and Russia, Director General CBI from 95 to 99, Senior Advisor to Merrill Lynch Europe, Non-Executive Director of Standard Chartered Bank, has been Chairman of the Pensions Commission and the Low Pay Commission, and is now Chairman, as I imagine everybody will know, of the Financial Services Authority, the FSA, and he is a colleague as a crossbench independent peer in the House of Lords. And he will speak first, and then Professor David Sugden will speak second. David is a Fellow of the Royal Society of Edinburgh, and he chaired recently our inquiry into climate change, which produced its report last year, and which I hope many people here will have read. He is Emeritus Professor of Geography at Edinburgh University, having previously been for many years in Aberdeen. Research interests relate to behavior of glacial and ice sheets, particularly in Antarctica and Patagonia, and he was a scientific officer with the British Antarctic Survey in the 1960s and was awarded, which is really quite an achievement, the Polar Medal in 2003. And the Polar Medal, if you follow Wikipedia, is awarded for extreme human endeavor against appalling weather conditions that exist in the Arctic and Antarctic. David, we're very glad to have you here. Adair, we're very glad to have you two here. And Adair, if I could ask you, you would speak first, and then David Sugden. Thank you.
Well, David, thank you for that introduction, and good evening, ladies and gentlemen. It says on the programme, I think it said on the programme originally, that I was going to talk about the recommendations of the Climate Change Committee for the fourth carbon budget, and I will mention that, I will cover that, but I thought here at the Royal Society it would be appropriate to place the work of the committee within a wider context. The Royal Society is devoted to bringing together the insights of multiple disciplines. Its fellows and presidents have come from scientific, from technical, from moral philosophy, from literary backgrounds. And what is interesting is that it is a wide mix of disciplines which are relevant to the challenge of climate change. And the optimal way forward for climate change, the appropriate way forward, involves thinking, as I put here, about science, about technology, about economics, and about ethics. So what I'm going to actually organise my comments around is saying how the Climate Change Committee has taken into account those four different categories of discipline. First, then, the science of climate change. And I think in communicating the science of climate change, we do face a clear challenge. And the challenge is how to communicate the high degree of certainty which science gives us about the direction of climate change, while still honestly explaining the uncertainty and thinking out the implications of the uncertainty of the specific extent of climate change and its regional impact. And I think that is particularly important because people who are sceptical on climate change often take uncertainty about particular details to rhetorically cast doubt upon our reasonably high level of certainty about overall direction. I think it's also particularly important in the face of the various climate change gates, climate change scandals, as it were, that we've had of the last 2 years, the assertions that some climate change scientists have massaged data or oversimplified results, because I do think there is indeed a danger that scientists who are trying to explain the thrust of climate change science and to win an argument can sometimes try to simplify it in order to get the message across, but in a way which then opens up a challenge. So it is important for us to recognise both what it can tell us and the uncertainty. But I actually believe that the degree of uncertainty in the detail is an argument for action rather than inaction. So what does science tell us? Science tells us with a very high degree of certainty of basic physics that greenhouse gases in the atmosphere warm the world. Indeed, if there weren't greenhouse gases in the atmosphere at a reasonable level of concentration, the world would be about 30 degrees colder and there would be no human life. And that is pretty much definitive. That is pretty much definitive from the physics of the way that greenhouse gases work. Secondly, there is a pretty good empirical data which we know with a high degree of certainty, which tells us that for the last 1 million years or so, this chart shows the last 500,000, but the ice core data can now push it back for 1 million years, there has been a very significant correlation between variations in the concentration of key greenhouse gases in the atmosphere, shown here in blue CO2, in green methane, and proxies, as best possible, we can develop for average temperatures. Now, what the sceptics immediately point out, of course, is that correlation is not causation, or at least the causation could work both ways. And what is absolutely right in that historical record is that the causation has nothing whatsoever to do with man-made emissions of carbon. The causation over that period of time is actually starting with the temperature and is starting with things induced by sun cycles, by cycles in the intensity of solar radiation reaching the Earth. And what is happening in that is that it is those natural variations which stimulate an increase in temperature, which then stimulate an increase in CO2. But although that is true, we shouldn't take any reassurance from that, because what you then find out is that the increase in CO2 which subsequently occurs is far bigger than you can explain by the initial stimulus of the change in the radiative intensity of solar radiation. Because what is going on is feedback loops. Things that generate an increase in temperature, which generate an increase in CO2, but where that increase in CO2 then feeds back to a major further increase in temperature. So what that tells us is that we live in a complex climate system with complex feedback loops, some amplifying, some damping, but for large periods of time, potentially very significantly amplifying. And what that says is we should be pretty wary about autonomously, exogenously changing the quantities in that large chemical experience. And then what we know, with pretty much to total certainty, is that we have changed a key quantity. And that's that blue line on a far different timescale over on the right-hand side. We know pretty much definitely that carbon CO2 concentrations in the atmosphere, which over the whole of the last million periods had oscillated in a band between about 180 and 280 parts per million, have grown to about 390 parts per million and are growing at about 1.5 per annum. That's pretty much as close to a fact as possible because it's based upon empirical observations. And we know with pretty much close to certainty that that increase in CO2 emissions is driven by fossil fuel burning and by other man-made forcing devices. And why wouldn't it be? We take out of the Earth fossil fuels, which are the stored residue of CO2 that used to millions and millions of years be in the atmosphere, which was taken out of the atmosphere through processes over tens of millions of years, and we burn it and we release it. So what we are doing is that we are on a path to double the amount of greenhouse gases in the atmosphere, which we know have a major influence on a complex, interrelated feedback loop system. Even if we did not have an ability to attempt to estimate what that would produce, that would be an argument for action. It would be an argument for extreme caution about the impacts that we are likely to produce. But what climate change modelists then do, and economists and social scientists who've thought about the impacts, is take that overall insight and turn it into models of the climate change impact and estimates of the potential impact on human welfare. But what we need to recognise is that when we go from the general insight that we are taking a huge risk and that there is almost certainly man-made climate change into precise estimates of that, we are inevitably dealing with high degrees of uncertainty. We need to go through these five-step process here. Now, the ones on the left-hand side, the relationship between emissions of greenhouse gases and concentrations in the atmosphere, that's pretty much fully understood. And the emissions, we can measure, we can develop scenarios of how much they will go up as the world grows. Where it gets really complicated is turning any level of concentration of emissions into estimates of how that might drive future temperature increases. And given the potential complexity of the feedback loops that exist between primary effects and secondary knock-on effects, either dampening or amplifying, the climate scientists cannot give us a certainty that says the average temperature will increase definitively by 1.7 degrees centigrade. All they can give us is estimated probability distributions of what the impact might be. And therefore, intelligent policy, and this is a very difficult thing to explain to people because people like certainty, intelligent policy has to respond to probabilistic estimates rather than to single-point certain estimates. But then it gets even more complicated because even if you knew that the average temperature was going to increase by 2 degrees centigrade, and you knew that definitively, the ability to turn that into what the regional climate change effects would be, what that means in terms of temperature in a particular area of the world, but even more crucially of, for instance, rainfall patterns in particular areas of the world, further uncertainty is introduced. And then there is further uncertainty in translating to that into, well, what effects does that have, either positive or negative, on human welfare? We have all sorts of reasons for believing that, on average, the effects are negative. There may be some positive effects. And we also have a very strong reason for believing that the effects are non-linear. That if there are adverse effects from going up by 2 degrees centigrade, the impact of going up by 4 degrees centigrade is not twice as bad, it is much worse than twice as bad. And indeed, there is a point beyond which we begin to have potentially catastrophic effects. So, given that, how did we, as the Climate Change Committee, when we were asked by Parliament to recommend a target for the UK for 2050, how did we set about it? Well, we spent time looking at the estimates that the scientists had produced of the probabilities of going above certain increases of global temperature over the next 100 years. And what this is a cumulative probability distribution. It says that these are different scenarios. I won't go through them, but the green, the red, and the blue line are just different scenarios for how big the emissions are, when they peak, and how rapidly they reduce. But what it essentially says is that if we were on the emission line 2016 1.5%, we would actually have a 10% probability of going above 3.5 degrees centigrade increase, and a 3 or 4% probability of actually increasing the temperature by more than 4% or so. And most of these, you will see, give a very significant probability of exceeding 2 degrees centigrade. And I have to say that although there are many climate change lobbyists, people arguing for climate change action, who demand a global target that assures that we don't go above an increase of 2 degrees centigrade, I think that is undeliverable. We simply cannot be certain that we will go above 2 degrees centigrade unless we slam the brakes on immediately and start pulling CO2 out of the atmosphere. So that's what the science is telling us. It is uncertain, it's probabilistic, but we've got to decide how to respond to it. Then we looked at what best estimates can tell us about the potential impact of climate on the world. And these are some of the estimates of what might happen in terms of things like European heat waves or Peru's glaciers melting, or the potential impact of rainfall in Africa and the movements of people that drought might produce. And what you'll find looking at that is there are a very varied set of impacts. And one of the challenges when you take that varied set of impacts is trying to think out how bad that is for human welfare. And one of the essential problems that we have is that some of the impacts of climate change we can pick up and at least turn into the language that economists like. Economists like to say, well, what is this going to do to agricultural productivity or to GDP? And so changes in agricultural yields, the costs of sea defences, the losses from extreme weather events, they may be uncertain, but at least we can attempt to put a GDP value on that. But then we have a whole set of potential impacts which are incredibly difficult, even conceptually, let alone operationally, to put a value on that. How do we value deaths from heat waves, or indeed less deaths from less extreme cold? If we have spreads of tropical diseases, how much do we count a human life? If we have political and social disruption and movement of people because areas of Africa become arid and people move elsewhere, how to put a value on that? And if it simply changes countryside or environmental balances, loss of coral reefs that people love for reasons of beauty, how do we put a value on that? So when we look at all these things, we are trying to decide how to respond both to some things which are capable of measuring in the language of economics and some things which are highly relevant to human welfare but not easily reducible to any GDP calculation. So what did we do on the Climate Change Committee? Well, we looked at those probability distributions. We looked at the evidence on the possible impacts on human welfare. And we ended up believing, and it was a judgment, and you have to accept that there is judgment required on this, that a sensible aim for the world was the following. We believed that taking the evidence of science as our guide, we had to set on a path of global emissions which would keep the increase in temperature as little above 2 degrees as possible. We wanted the chance of going above 2 degrees as maybe no more than 50%. We'd prefer to have the mean expectation about 2 than 2.5. But crucially, this is what the most crucial rule we had. We said we have got to keep very low the probability of really catastrophic change. Again, judgmental. We defined very low as below 1%. We defined catastrophic change as 4 degrees centigrade. But there is a very good argument in human welfare for placing a high importance on the avoidance of catastrophic events. And what that led us, with the guidance of the science, was to the belief that whereas today the world is putting out about 48 gigatons, billion tons of CO2 equivalent across all the greenhouse gases, the world had to get that down by roughly 50% to somewhere 20, 24 gigatons by 2050, or 8 to 10 by the end of the century. That was what we took out of the science and the evidence on potential impact, judgmental necessarily. But then the next question was, OK, but if that's what the world should do, what should the UK do? Should we reduce by half? How do you think about that? And when you think about that, you cannot avoid thinking about ethics. Some of the relevant facts are, today, total emissions, and this, by the way, is not GHG. This, it's wrongly headed. This is CO2 emissions, because they're easier figures to get on a breakdown basis. So 30 gigatons is just the CO2 bit, not the methane bit. And that gives you an idea of the breakdown geographically. China now the biggest emitter of CO2 in the world, 24%. US 18%. Where are we? Well, we are, of course, a sliver of this. We're about 1.5% of global emissions. And, of course, that then creates an immediate ethical issue, because some people will say, well, if we're only 1.5%, what difference does it make what we do? I mean, we could halve it and that won't count for anything if the Chinese continue to increase. But the point is, if you make that argument, you would never obey any speed limit. I mean, maybe you don't, but you'd never pay your taxes, you'd never obey any law, because your individual contribution to paying taxes or being obedient or not chucking a litter on the street is so minor not to make any difference. We, all of us living in a society, make contributions which are trivial to human welfare seen on our own, but we are part of a social contract where we all agreed to do it. So I don't accept that free rider argument, which is, I'll just do nothing and hope that the rest do something, but you will get that argument. The other relevant fact here, of course, is the CO2 per person levels. Look at those figures. We were, in 1990, on CO2 about 10. We're now down about 8. China, very worryingly, up from 2 to about 5 already. Probably actually overtake us by 2015. But look at the figures for Africa and India, down about 1. Here's the reality of it. If we want to reduce emissions, first of all, we have got to do a deal with China. We've got to persuade them never to go to the levels that America went with and begin to reduce that. But the lead has to be given by the countries which have high levels of emissions today. First of all, because we actually are sitting on all sorts of economic opportunities to reduce our emissions. Secondly, because there is some ethical concept here, some idea of a shared responsibility where I think the rich of the world have to show the lead. Now, of course, you could have a different argument. If you look at this chart, this takes from the IPCC, the international body, potential measures of climate change effect. And I'd ask you to look at the difference between the sort of words that they're using for Europe and for Africa. Europe, winter floods are likely to increase in maritime regions and flash floods increase throughout Europe. Crop productivity is likely to increase in northern Europe and decrease along the Mediterranean. Winter tourism in mountain regions is anticipated to face reduced snow cover. Well, there's quite a lot of things I don't like there, because I do like going skiing in the Alps, and there will be very major water pressure in the Mediterranean. I think overall net it'll be negative, but none of that is actually catastrophic. Whereas when you look at Africa, if we really did have projected reductions in yield, in some countries could be as much as 50%, and crop net revenues could fall as much as 90% by 2100, these are very, very significant adverse effects. Now, you've got to decide what ethically you do about this. Because I'll be absolutely blunt, there is an argument that although the impact of climate on the UK is unpredictable, and actually because of the nature of the Gulf Stream, it could either be colder or warmer, and it could be quite different for northwest Scotland from southeast England, you could argue that we are one of the least affected areas of the world, so you could say we're okay. But you've got to decide whether you do that. But it is an ethical decision. What did we do? We ended up believing that if there was going to be a 50% global reduction, we then looked at all the different alternative methodologies that people had thought of for how you divided up that reduction, that responsibility between different countries of the world. And we couldn't find a sensible way forward which didn't end up with roughly equal per capita emissions across the world. I don't think there's any magic about precise equivalence. And, of course, there are some developing countries out in the world there that say that Britain and America have got to go lower than them in the long term as a sort of penance for the Industrial Revolution. We've got to make up for our cumulative emissions. But actually, almost any form of global burden sharing which makes any sense will be roughly equivalent. I mean, think about it like this. If you are going to say that we as a country or any group of a country permanently or for a very long time is going to be above the average, you've got to find me a set of countries who are going to be below the average and whom you can do a deal with in which they think it's fair and reasonable to stay below the average. Given that I cannot think that you will ever find such a country, nor do I think it would be fair to say to Africa or India, well, we'll have 3 tonnes per capita, you just make do with 1.7, I don't think there is a credible way forward which isn't roughly equal. And if you do roughly equal, then the UK, by 2050, if we get to roughly equal by then, has to end up with something like 2.1 to 2.6 CO2 equivalent tonnes per capita, and that's an 80% reduction below 2050, and it's 160 million tonnes per year. So that is what we recommended and what Parliament enacted. So, how then are we going to get there? What does getting there involve? Is it doable? And here we turn essentially to technology and economics rather than to science and ethics. In 2008, our total tonnes of emissions were about 670. By the way, by 2010, they were probably around 600. That illustrates that the quickest way to achieve emission reductions is to have a whacking great recession, but it's not the best way to produce emission reductions, and the government has to be very, very careful of patting itself on the back and saying we're well ahead of target simply because we've managed to have a large recession. 670 million tonnes down to 160 million tonnes. And our job on the Climate Change Committee is to work out how that's doable, by what mix of technologies and policies is it doable, and what should be the time path from here to there? What is a sensible path on that route from today to 2050? And we have to do that by recommending to government, and then government either accepts or rejects, but so far they've always accepted our recommendations. We have to recommend what are called budgets. Budgets are a maximum number of tonnes that the UK will emit in a series of 5-year time periods. We have now set the 4th budget. In our first report 3 years ago, we set budgets for the first 3 5-year periods, which were 2008 to 12, 13 to 17, 18 to 22. We have just recommended to Parliament, and they have accepted, a target of 1,950 million tonnes, which is 390 million tonnes per annum, for the 4th budget period, which is 23 to 27. We believe that it is possible to meet this 80% reduction target and the budgets that we are setting en route at a relatively low cost to economic growth. Now, why are we confident of that? Well, we're confident of that because we believe that there are a variety of ways of reducing emissions which, if you put them together, give us a believable path which is not hugely costly in terms of economic growth and certainly not of human welfare. Think about the ways that we can do it in 3 ways. We can either, down at the bottom, simply say, well, we'll have exactly the same lifestyle as before, we'll drive cars of the same size, we'll heat our houses to the same temperature, we'll fly as much, and we'll use energy just as efficiently as today, but we'll just produce energy from renewable sources or low-carbon sources, any category of low-carbon sources. Or top right, again, we don't change our lifestyle, but we take energy and we use it more efficiently, be it in our cars, be it in our homes, etc. Or top left, we change our lifestyle a bit. One of the biggest ways you can change your lifestyle is driving on a motorway at 55, not 70, and you'll find your household budget immediately goes up by a significant amount because you will have saved a significant amount by much higher fuel efficiency. That's a lifestyle change. Doesn't strike me as a very important lifestyle change. I could recommend it all to you, but I'm finding it quite difficult to convince Jeremy Clarkson and the Daily Mail that this is a sensible thing to do. However, we believe that there are a set of varieties of ways forward, primarily actually of that and that form. We don't put much in for changes in lifestyle. That would be an additional, which can drive the reductions that we need. What is the path? What are those technologies and what is the path? Well, let me say a few words about the shape of what we believe the technological path from here to there is. Point 1, it is led by electricity decarbonisation. At the moment, we have, in the UK, when we use electricity, we are emitting about 500 grams per kilowatt hour of electricity produced. We believe it is absolutely credible to reduce that to 50 grams per kilowatt hour by 2030 and to a much lower level, close to 0, by 2050. That is doable through a combination of technologies. We believe that it should involve, and I know this is controversial to some people in the Scottish Government and in the Scottish Parliament, we believe it should involve nuclear and renewables and carbon capture and storage. We are neutral between those three. We believe they all have a role to play, and we believe that if you knock one of those out, you make the challenge bigger. You get there at the lowest cost by using all the technologies available. But we do believe it is technologically available and not at an absurd cost. It is also true that we can achieve very significant improvements. Let's take another example in the emissions from cars. Here the measure is grams per kilometre travelled. We use grams per kilometre because there is a European standard on that. That's why we express it in kilometres, not miles, and that's how the measurements come. And what you can see is actually that new cars, grams per kilometre, have already come down a lot. They were about 180 in 2000, and they're now at 145. And actually, the size of cars hasn't changed much at all. There has not been a lifestyle change. It's just that once we started creating tax incentives for people to buy more fuel-efficient cars, and once we set tight standards on the European car industry, hey presto, they went out and found that they could create more fuel-efficient cars, and people started buying more fuel-efficient cars. And we think it is quite possible by 2020 to get that down to 95 grams per kilometre, and that could be done even with the existing internal combustion engine. But with the internal combustion engine, we will at some stage start hitting some limits. It will be difficult to get that down below about 70 if we simply rely on the internal combustion engine. And we therefore believe that beyond the internal combustion engine, there will have to be a role for electric cars. Now, some people at this stage say, well, why not biofuels? The crucial thing with biofuels is we've got to work out how many biofuels the world can produce in a sustainable fashion without that reducing biodiversity, competing for food, etc. And that is a finite amount. And once you've worked out what that finite amount is, where you would want to use that is in the applications where there is no alternative. Aviation. Nobody has worked out how to get a plane off the ground except with liquid hydrocarbons. We're not going to do it with batteries, that's for sure. So there, we have got to find a way which flies planes with liquid hydrocarbons. That says take your finite amount of liquid biofuels and devote them, first of all, to aviation. We believe that when you have devoted liquid biofuels to the things, or biomass used in heat, to the things where they are most efficiently used, we cannot plan on decarbonising cars with liquid biofuels. We will have to go down the electrification route. Now, the great thing about electric cars, though, is that net-net, they are very significantly more efficient than internal combustion engines. The point about an internal combustion engine is that its conversion of the energy input through to kinetic energy is only about 26–30% or so. As you drive along your car, 70% of the energy is going in heat. That's why it's so hot when you stand next to cars. When you run an electric car, the power through to kinetic energy conversion is about 90%. That means that even though in a power station you're losing some efficiency, because you can only get your power stations with fossil fuels up to 50% efficiency, even today, certainly if you're making your electricity from gas, a car of the same kinetic energy, i.e. capable of the same acceleration, would have a very significantly lower grams per kilometre travelled. And once we get our electricity from wind or nuclear or other low-carbon sources, then the grams per kilometre of an electric car become dramatically better than a fossil fuel car. Now, there is one problem, it's a rather big problem, which is how to store electricity. One of the biggest technological things to break in the world, the thing which will make people rich beyond the dreams of Bill Gates if they can get it right, is light, high energy density batteries. We believe that they are progressing fast enough that this will be a workable technology increasingly over the next 20 years. We are talking about scenarios in which of the new cars coming into the fleet in 2030, something like 40% or 60%, 50%, plus or minus 10% could be electric, and that will drive a significant decrease of emissions in the subsequent years, and it will drive car emissions down to a very small level. Let me skip over that and skip over that. What that implies, though, is that one of the interesting things about electricity, and again I do come back to this because I think we are on the verge of a sort of new electrical industrial revolution, is that we are going almost certainly to produce electricity far more carbon efficient than at the moment, but almost certainly much more of it, because we're going to start using it for surface transport, and also, I haven't covered this, but it's set in our reports, we will probably start using it in domestic heat. We will probably, within the next 20 years, we will probably have to start taking our gas central heating out and re-electrifying domestic heat in a fuel-efficient fashion through heat pumps. I was saying fuel pumps, so heat pumps. What a heat pump is, for those who don't know, it's essentially an air conditioning unit switched around the other way. If you stand outside an air conditioning unit, there's cold air coming in and there's hot air going out. And if you switch it around the other way, there's hot air coming in and there's cold air going out. And in a process which appears like people to magic, but it isn't, you put in 1 kilowatt hour of electricity into it, and you'll get 3 kilowatt hours of heat into your house. That's because you put -2 kilowatt hours of coolth on the outside. You get a conversion efficiency. That is the essence of it, and it's why it's an efficient thing. But overall, we believe that even when you allow for those efficiencies, with the application of electricity to heat pumps, domestic heat, and to surface transport, we are likely to, after a period in which we might reduce electricity consumption through extra appliance efficiency, actually see a significant increase of electrification looking forward. I'll skip over the comments I was going to make on household insulation. It's a very, very important area as well, but in the interest of time, let me now move to show you the shape of what that means. When we were thinking about setting the fourth budget for 2023 to 27, we thought that it would be useful to pose the question, where should we be in 2030? Just as a communication device, 2030 is halfway from when we were reporting in 2010 to the 2050 target. Where do we want to be in 2030? And what does that imply for the 23 to 27 fourth budget? And we believe it is possible by 2030 to have emissions down to something like 360 million tonnes, but with a very particular shape. A very dramatic reduction in emissions from power, a significant reduction in emissions from transport, and then a big decrease thereafter. A very significant reductions in buildings, in particular residential buildings, from a combination of better insulation, better appliances, and the electrification of heat. But then notice some segments which actually don't, from today, decrease all that fast. And they include agriculture non-CO2 emissions, other non-CO2 emissions, and international aviation and shipping. And indeed, one of the challenges that we have is that within the story looking forward, there are some segments of the economy where it is quite straightforward to see what the technological opportunities are. There are others which are much more difficult. We think with aviation, even if we try very hard, it will be difficult to do more than simply cap aviation emissions today in 2050 as well. But as long as we've reduced other areas of the economy by 90%, that's adequate. Agriculture is an area which is incredibly difficult to reduce emissions in, but we are going to have to do more in that area. But we believe there is a believable story which takes us to 360 million tonnes by 2030 and to our 160 million tonne target by 2050. We also believe that this is doable at a very small cost to the economy, and I'm going to be finished by setting out why we believe that is the case. Our conclusion on the costs to the economy are very much in line with those that Nick Stern reached in his report on the economics of climate change. If we don't act, wrote Nick, the overall costs and risks of climate change will be equivalent to losing at least 5% of global GDP each year, now and forever. If a wider range of risks and impacts is taken into account, the estimate of damage could rise to 20% of GDP or more. Now, Nick himself says that in that first paragraph, he knows that people want to be given that figure, but he'd almost rather not have done that. He'd almost rather have said, I will write out over 5 pages all the nasty things that can happen. As best I can do, I'll put a figure on it, but the crucial thing is, as a human being, to look at that and decide you don't want them. Because the process of quantification of the harm of climate change is an inevitably judgmental process. But what is far more rigorous is our ability to work out the orders of magnitude of the cost. And Nick's estimate was, in contrast, the cost of action, reducing greenhouse gas emissions to avoid the worst impacts of climate change, can be limited to around 1% of GDP each year. Now, our latest estimates suggest that for the UK to reach our 80% target, maybe it's 1.1%, maybe it's 2%, maybe if we've got our figures wrong, it could be 3 or 4%. There's nothing, we can't be precise here, but we're absolutely sure it's not 20%. And I just want to finish by saying, suppose it was 2% for an illustration. What does that mean, and why are we confident that it is roughly that order of magnitude? Well, 2% means that the GDP in 2050 will be 2% below what it would otherwise be. Now, despite the current recession, it is a reasonable expectation that between now and 2050 we will grow. We might have a per capita income by 2050 which is 2.4 times the current level if we grow at the sort of typical level of a rich, mature country. So, what is the impact of the 2050 GDP per capita being 2% lower? Well, it's the difference between sort of the blue line and the red dotted line here. I put it, there's a range that I was indicated on this chart, 0.3 to 2%, but however you do it, you're hardly able to see it. What it would mean, actually, is that given that the economy grows at 1.5%, 2% per annum, we would reach, in about February 2051, the standard of living we would otherwise have reached on January the 1st, 2050, a standard of living about 2.4 times our current standard of living. Now, if anybody thinks that that is a major cost for human welfare, I just don't agree. I think that is relatively minor, indeed, really minor in the scheme of things. And I actually believe, first of all, that people wouldn't notice it at all. I actually think in human welfare terms it's zero, and I also think it's entirely credible. Why is it entirely credible? Because if you go back to this chart, first of all, there are a set of ways of producing renewable, low-carbon energy, which, as a percentage of GDP, is not a very high cost. Now, people say, how can that be true? Wind energy, they'll say, well, 50% more expensive than coal. Well, yes, maybe at the moment that's true. But how much money do we spend on electricity? About 3 or 4% of GDP. So suppose we had to pay 50% more for all our electricity. What's the cost of that as a percent of GDP? 50% of 3%, 1.5%. I mean, the fact is, energy is not all of GDP. Energy in total, depends on the oil price at any one particular time, about 6% of GDP. So as long as we can find ways to deliver that energy at 30% more cost, then it will only be 2%, even if we only have that element of the solution space. But if we've got some of the top right, and there are lots of opportunities to actually improve energy efficiency, which are either low cost or many of them are nil cost. Basically, lots of people sit on opportunities to insulate their houses where the return that they will get in a lower cost of running their house will more than pay the capital. The challenge is that there's just a hassle factor in getting from A to B, and we've got to help people over that hassle factor. But the overall cost to people's standard of living in the long term is small. Finally, if people want to change their lifestyle, they can do that in ways that won't make them worse off at all. If we can persuade people to get out of their large cars into smaller cars or into bicycles, actually they'll have more money to spend on other things, and I can assure you there'll be much, much happier people as a result. My final slide is simply this. We shouldn't really care in the rich, developed world if our GDP per capita in 2050 does end up, on a measured basis, 1 or 2 or even 3 or 4% less than it is at the moment. Because actually, there is an overwhelming body of theory that suggests that beyond a certain level of GDP per capita, which is the sort of GDP per capita that we reached about 20, 25 years ago, that there is no correlation between human well-being and welfare and happiness and GDP per capita. It matters a hell of a lot to the average person of Africa whether they get an increase in their measured economic GDP per capita from the sort of levels of $1,000 a day to $30,000 or $40,000, $1,000 a year to $30,000 or $40,000 a year. Once you're at that level, all of the evidence suggests that actually the impact of minor incremental improvements in growth has no major impact on human welfare. Overall, therefore, I believe that from the combination of science, technology, ethics and economics, the case for robust action on climate change is very strong indeed. Thank you very much.
Thank you very much indeed. And now, Professor David Sugden, please.
Well, Adair Turner has given us a very broad survey of the reasons behind their concern with climate change and also outlined a blueprint. What I want to do is to talk about the background to our inquiry, because what we were addressing was why is it so difficult to implement this sort of blueprint? Why is society so resistant to make this change? As background to our inquiry, which began in 2009, we really took two decisions. One is there was a risk. The science showed there was an enormous risk for society. This is a graph which we've just heard about. And what this shows is that the temperature fluctuations correlating with the carbon dioxide, and there on the right of the graph, the sign that the carbon dioxide in these Vostok ice cores is well outside the natural variability. If you take the natural variability there, we'd got it up to there by 1999, and now it's off the top of the graph. Clearly, if one's playing around with and modifying a greenhouse gas, then this is likely to be amplifying the situation and giving us an uncertainty. So there's a risk, and the more uncertain the future, the greater the risk. So that was one of our underlying principles. The second one was that at the time, the realization this wasn't an environmental problem. It was the depth of the climatic problem was actually posing a challenge to the world. So it's a global issue, and also as it's one that's more than just the climate. We could have taken lots of quotes, but this is one from Desmond Tutu at the top, making clear and very eloquently how it's a global issue and how it's more than a climate one. And also there's a responsibility for the richer world to help the poorer world. And then below is the same one that we've already seen, Nick Stern's view, that there was enough. There is a solution to this. We could actually find a way of transferring from fossil fuels to renewables. Well, with that background, this is what the inquiry set up to do. How can we bridge the gap between the policies needed and what people currently will accept? And in particular, we tried to look at the opportunities and the barriers to change. The committee was 8 strong. It was interdisciplinary. We had natural scientists, economists, social science, sociologists. We had people from business. We thought we would engage with the schools, since this is the generation that will have to deal with the problems. And we have people dealing with policy. We were supported by a whole variety of organizations who covered the costs of the inquiry, which gave us this magic ingredient of being independent. The inquiry activities, we took evidence from 110 organizations. We had public meetings. We went to exemplar case studies. We participated in seminars, organized our own seminars when required, held a schools competition, and produced a film. And the results are all there. What I want to do here is simply take a few of the issues that arise from our work, these general issues. And these are identifying the barriers that are making it difficult for the country to actually make the change, and also the recommendations for the changes. The first thing that really struck us was the optimism and the vision that we got from all walks of life and all sorts of locations in Scotland. That if you accept that there is a renewable revolution, an industrial revolution in the world, then Scotland was incredibly well placed for this. We have the landscape, we have compact cities, which are easier to deal with, lots of universities, offshore skills, the renewables. We're close to the European core where the demand is. So there was an opportunity, and a lot of people saw that this was an opportunity. But there's another one that, unlike the past industrial revolution, which centralized people and took people off the rural areas, this one had the opposite. Here was a distributed one which could actually bring prosperity to rural areas as well. And so with local communities participating in this future, there is this vision of getting economic and social well-being both in rural areas and urban areas. So that was our first discovery. What I want to do now is just very briefly mention this one. This seems to be the best forum to do it when we're representing the UK as well as Scotland. One of the issues that we came across right at the start, and this is our first recommendation, is that the lack of coherence, apparent coherence, about issues such as the grid. And the question is the strategy clear? Are we clear about how we're going to develop the renewables in Scotland? And below here, in the points that you see, there are different views, and we thought it was well worth airing these different views. There at the top is the view we heard from the National Grid that renewables are a temporary fix on the nuclear road. They had a vision in 2050 of a centralized grid based on nuclear power. DEC, we were glad to see that renewables are one of the three prongs needed and are vital to the UK in the long term. When we spoke to the EU, there was a view expressed to us that will be no full exploitation of renewables in Scotland unless there's a link to the continent, an interconnector. One reason is simply that if one's connected to Norway, as is Denmark at the top, you can call on the pump storage in Norway to generate electricity when you need peak demand, or when, for instance, the wind isn't blowing so hard. And then you can export it back when conditions are the other way around. The other dimension there is if you want to export from northern Britain to Europe, then an interconnector will be necessary if people are going to invest in the tidal energy and so on. And then there were questions about access to the grid and the nature of the grid and the management. We simply just highlighted that issue, is that there are quite different views around, and unless there is coordinated linking between the UK, the EU and the Scottish Government, then it may be that one of the fundamental things we need to exploit the renewables may not happen. Another of our main findings is the importance of city regions and the problems that city regions were having in making the savings. The city regions have the best potential for carbon savings. This is where most people are. This is where most investment and prosperity is. This is where it's easiest to make the changes that are needed. And we discovered there was, talking to the local authorities, significant barriers due to a whole series of issues. The conflict between national and regional goals. This might be a surprise, but if you, as some authorities did, try and get another commuter station opened, then it's conflicting with the national goal. The national rail network wants quick intercity times. The commuters require more stops in various cities. And there were cases with commuter stations being ruled out of court because they conflicted with national goals. The same can be said of trunk roads. Glasgow can't even contemplate a congestion charge since it's got motorways running through the middle. The same can be said of finance, that finance is nationally based rather than regionally based. And there are many other examples. So that was one issue. Second issue was the lack of appropriate powers. One comment made to us was, we can't even get the architects, the building surveyors, and the planners to agree on what type of heating you should put into a new development. We came across cases when new built houses are being built at lower standard than they should be, simply on the grounds of negotiations between developer and the council. If you're in the council and a developer says we can build you a new school, if you accept lower standards of insulation, you can have an extra gym. That was one case that was used for us. Other ones, authorities are facing the problem of different developers negotiating with alternative authorities. For instance, saying, if you're going to set this standard, we'll move to this one where standards are lower. So we're building new houses at the moment which are below optimum standard because of these lack of these powers. Then lack of integration across all activities. One of the things that's happening in the local authorities is that individual divisions within the local authorities are meeting their carbon targets, but much more could be achieved if these things were integrated. An example we were shown two buildings which had beautiful credentials, environmental credentials. Both were outside town, both had big car parks, and one wondered about the long-term efficiency of those buildings. But we have difficulty, fringe effects around the cities, where standards set within a city may then be subsumed by a council outside, and therefore you get the houses built more cheaply, much further than is desirable, and the out-of-town shopping centres, etc. What was very clear here was just the lack of planning, a strategic planning, which was, because it was absent, meant that in transport, in energy efficiency, we were not achieving what could be done. And there below, the fairly obvious things that need to be done. The energy efficiency, district heating, that is something which is commonplace in Scandinavia. We seem to find it difficult because of those lack of powers and those issues above. Decentralized power, you have combined heat and power. Municipalities in Sweden all have their own power station burning their own garbage. We need public transport at a regional scale. This is the one, it's the commuting by car is the one where we can make a big difference. Active transport, urban areas, etc. Lots of opportunities for moves which don't necessarily cost anything or very much, and yet can make reap a big reward in saving. Then another main finding we had was that we were surprised and frustrated to discover just how much activity there was at local community level opposing developments like wind farms. We went to one developer and asked about NIMBY, and he said, it's not NIMBY, it's banana. Build absolutely nothing anywhere near anybody. Yeah. And it does seem tragic that the energy is being dissipated in opposing the future. And we did go to two impressive examples, which I just want to mention. The one at Westbury at the top was, this is an island in Orkney, which after the failure of the decline of the fishing industry was losing population. They got together as a community. They managed to get a loan from the Troodos Bank. They had to go overseas to get a bank that would actually lend. And with the help of the lottery fund as well, they built this turbine. They located it where they wished, and they've now got, they're generating their own electricity. They're earning an income, and they've used that income to actually improve facilities on the island. The population decline has been reversed, and they're moving ahead with other plans. It took them 700 legal documents to get that wind turbine erected. So there's one example. Why can't that be more widespread? And then in the middle, we've got Mackie's. We visited Mackie's as one of the farm in Aberdeenshire as one of our visits. And this is quite an interesting graph, which is on the website, and it just seems worth pointing it out. The blue is the purchase that the farm makes from the grid. This blank is when they created 3 wind turbines. What you see is after the turbines are there, the electricity purchased from the grid declines. The yellow is the energy generated on site, used on site, so it sees an expansion in use of electricity. And the green is profit. And the green in 4 years paid for the wind farm. We were extremely impressed with this and wondered why on earth cannot this not be expanded across Scotland. Any hospital, any school, any community in Scotland that needed to generate income, this is a model to follow. So it just did seem that here's opportunities galore at that sort of level. And then the final sort of major point that we had was the importance of civil society. And when one looks at contrast what's happening in countries like Scandinavia with here, it's obvious that we don't have civil society working easily alongside the market and the state. We've got the friction within civil society sometimes, where environmentalists may oppose wind farms, but we also have the friction between civil society and the market at the moment, as illustrated by the opposition to the wind farms. The sorts of things that seem to need to take place. Education, we need to see that it's not just recycling or just transport. Every activity and our way of life affects our carbon footprint. One thing that definitely needs discussion is the imported carbon, that although our emissions may be going down, the import of carbon is actually increasing the carbon footprint. Well, this needs to be discussed. We need for an open and mature debate. Is it possible that we could ask the media to contribute to this as they have a stake in the society? And it would be good to see that, to feel that we could actually have a mature debate about these longer-term issues, which are rather than controversies and short-term issues. Bring together the environmental faith and social NGOs. I think this is something which has happened historically. It's been seen as an environmental problem, and the running's been made by environmental groups. But when it's seen as a social problem, and the environmental faith and social NGOs are all pushing in the same direction, it'll be much easier for the politicians to take the sort of decisions that are needed. We do make the point of invest in infrastructure rather than behaviour. We have a whole chapter on how society responds to change. We're not great fans of nudge economics and nudging behaviour. Yes, it's all useful if people use less water and drive more responsibly. But in order to get the step change, one needs to get engage society more thoroughly than that. And so that is the case that we make. Community partnerships, and the key problem is always this access to local finance. That seems to be the problem. There's a multiplicity of schemes which come and go, and people locally are confused. And the last one, the bold political leadership. So my last slide, just the reflections. I think we've underplayed the opportunity that's confronted by this revolution. If one stresses that, you can have a more balanced view about the climatic arguments, about costs, and about banana attitudes. I think the overwhelming conclusion that we reached is that it was the lack of coherence between different policies at different levels and different organizations that was impeding progress. But worse than that, it was breeding cynicism. If a person sees that these obviously don't fit, then you get a cynical public. I've been talked about the importance of the city regions. If everything we did in our city regions focused on a low-carbon infrastructure, that would make a huge impact. The importance of local communities is there, and the importance of civil society. At the end of the day, we wrote this report, 186 pages. We realized no one would read it at that length, and particularly not those who are not engaged and in the whole issue. And so we did try a 2-minute film. And if you could, I could take your patience, would like just to show this 2-minute film. It's on YouTube, and it summarizes what we were trying to get over in our report.
Well, thank you both very much indeed. And now is a chance for people to put questions or comments, and then we'll throw them at the panel. There are microphones on both sides, so if you could indicate that you want to speak, a microphone I'll indicate where the microphone should go. It's quite helpful, I think, to those who are answering questions or comments, if you say who you are and if you have a particular affiliation, say, to a department of a university or an industry or whatever it might be. I think I might start off with getting groups of questions, because that'll get us more questions together. So if I take 3 at a time, where would I start? Yes, just by the microphone over there on my right, and down here on my right again, and the further one back, who had a hand up first after the first microphone. Those 3, please. Yeah.
Hello, my name's Andrew Montford. I have no affiliation. I'm a blogger. In your 5th slide, Lord Turner, you showed the climate impacts around the world. Now, and the sort of financial cost, as it were, of in each place around the world of various climate impacts. Now, my understanding is that there is not a single climate model anywhere in the world that has ever been shown to have any skill at regional level. Therefore, is that not essentially a work of fiction? The other thing I wanted to take you to task on was your last slide about Layard and the happiness, which you said there was an overwhelming body of evidence that more wealth past a certain level didn't lead to extra happiness. Now, and that there really wasn't any doubt about this, but Layard's study has been repeated by somebody else with a much larger sample size and came to completely opposite conclusions. Would it not have been better if you had mentioned that?
Down here and then back to the...
Hi, Rod Dallett, retired in Edinburgh. I'm very impressed by the arguments you put forward. I'm quite reasonably willing to believe that the UK...
Sorry, just come a wee bit closer to your mouth with the mic.
I could easily believe that the UK can achieve these numbers, but how will you convince the USA to go in the same route, who have so much larger a problem?
Thank you. And then there was, we went further to the back. Well done. Thank you very much.
My name is Mallory Wober. I'm a visitor from the Royal Society of Arts in London, and an early slide showed us the role of carbon dioxide and of methane in relationship with the increase of temperature. Much of the discourse dealt with steps to try and reduce the production of carbon dioxide, and I don't remember, but I think nothing was said about what we might do about methane. So it's just a question about methane, please.
Thank you very much. Adair, would you
Okay, well, let me go number 3, number 1, and then the hardest, which is the one on the US. Methane is incredibly important. Per ton or per whatever put up there, it's a much more powerful greenhouse gas than CO2. So fortunately, it exists in much smaller quantities. I didn't mention it, but it is very important. First of all, it's important to the potential non-linear feedbacks within the models. If we end up warming the Earth to a level which, for instance, starts melting the Arctic tundra, we may then release large amounts of methane. It's one of the factors that could make the thing run away from us above a certain level. So it's important to the science. It's also important to UK climate change targets, in particular in 2 respects. Our 2 major areas of production of methane are from landfill sites in waste landfill sites, and cows and sheep. produce methane. There is also actually fugitive gases in the gas distribution system, and non-trivial. I mean, basically, if there's leaky pipes and any of that goes up, that's important. But it's the agricultural output and it's the waste is particularly important. The good news is that the waste, that is one of the things that's come very significantly down. You may not have spotted it on my chart, but the bit which had non-agricultural, non-CO2 emissions actually has come down a lot between 1990 and 2010, as we have very significantly reduced landfill methane emissions. The really tricky bit now is to achieve further progress, and it is agriculture, which I did flag as a particularly difficult area. And we have no clear technological fixes to that. There are people playing around with changes in diet of cattle, which may make a difference. And then, of course, you get to incredibly controversial things like genetic engineering so that they produce less methane, etc. But it's a vital area, and in our reports we do deal with it. To the blogger, non-affiliation blogger, 2 points. Happiness and wealth, I absolutely agree with you. There isn't much debate. When you're going through something at this speed, you have to make a cryptic point. I gave a lecture last year, the Lionel Robbins lectures at the LSE. They're shortly coming out as a book. And in that, I discuss at considerable length the variety of evidence which comes from people like Bruno Frey, Andrew Oswald, etc., on the one side of the argument, and Angus Deaton and Justin Wolfers on the other side of the argument. I am well familiar with their stuff, and the arguments that they make are arrayed in my lectures on that. I think if you look carefully at that, the balance of the argument is clearly on the side of the Layard-Bruno Frey point of view. I think, and it is certainly the case that beyond a certain level, the relationship between a GDP and measures of well-being is highly uncertain and I think breaks down. But you will have to read that if you want to see the full argument. But I can assure you, I have gone through in detail the arguments from Justin Wolfers. I've read his papers and I do set it out, and you will see that in the full-length version of that, I admit that there is an argument on either side and I explore it. On the point where I put up a slide of regional effects, you are quite right to say that it is very difficult from climate models to be absolutely certain what is going to happen in Sudan and Eritrea and Ethiopia. In fact, there are some models will show that particular area as having more rainfall, others as having less rainfall. What you have to do to a degree is say, look, here is an illustration out of the most likely models, but the crucial point is actually that we don't know. And actually doing something where we don't know is very dangerous, because what we fundamentally know from the climate change models is that there will be very big effects which we cannot predict. We know that a warming world will very significantly change the hydrological cycle. Overall, it will tend to mean more rainfall. That is undoubtedly the case. There will be warmer seas, more evaporation, more rainfall. But we are absolutely certain that it will mean more rainfall in some areas, less rainfall in others. And that's all you need to know to establish the case for action, because it is a dangerous thing for human welfare to simply throw into the ecosystem a set of changes. It really doesn't matter whether we know that the less rainfall will happen in Western Africa or Eastern Africa. If it's going to happen in one or other of those, we're going to have an adverse impact on human welfare. So I accept entirely that there is high degrees of uncertainty when you get to regional level models, but I don't accept that that is an argument for inaction. Indeed, I think the very uncertainty, I think this is where the skeptics are wrong. They argue that uncertainty in detail is an argument for inaction. Actually, uncertainty creates the risks. If we knew exactly where it was, we could plan to adapt to it. It's the uncertainty of how big it is that says we've got to place more focus on the mitigation. On the US, I actually think this is our biggest problem, and it worries me more than China. When I go to China, I find more engagement level with this issue. I think China will have a plan to peak its emissions at maybe 10 or 12 tons per capita. I wish they'd try and peak at 8, but they are talking about that. They are responsibly engaged with it. I think one of the most depressing things is to go to these debates in America, where I think there is some of the sceptical points there are just criminally wrong. And I draw a distinction. There is a point of view within the skeptic community which is responsible criticism, but there's a point beyond which they are just misusing data, often driven by industrial lobby groups. And unfortunately, quite a bit of the American skepticism, unlike I think most of the skepticism in the UK, comes from that direction. I don't know how we overcome it. I think the good news in America is that America remains an extraordinary place for creating new technologies. And underlying this dreadful political situation in terms of an inability to get commitment there are very interesting things going on in that great sort of technological machine which is the American universities and American industry. So that is a positive sign to balance what other is, I'm afraid, a very negative story.
Thank you very much. Do you want to
just one point on the regional issues and prediction. We're just faced with a complex system where we will never have the certainty. One thing we suggest in the report is, in any region, you can look at your statistics of the last 100 years, look at the variability, look at the trends, and then assume, as the models do suggest, that the extremes will be greater than they have been in the past. And so that would be rely on the observations in one's planning.
Thank you very much. Other questions? I've got one here. I had one right at the back, who's first of all, and then I'm going to take, not yourself, sir, but the gentleman in the light-coloured jacket. So 1, 2, and then down here at the right.
My name's Robert Hodgert. I'm an urban geographer, somewhat retired. I'd just like to say it was very interesting to hear so many comments relating to urban studies and what I basically regard as urban geography, all of which generally made sense to me. I'd like to add 2 comments. One is that there is evidence from urban studies that compact cities, which are desirable in terms of things you're talking about, tend to be found to be more attractive for people to live in. The more intense, give a more intense and possibly diverse urban experience, so that's an extra benefit possibly. And on the United States problem, my knowledge is very patchy, but I understand quite a number of American cities signed up to the Kyoto Agreement as cities, despite the national government's rather negative attitude. But at the urban level, and many American cities have been investing in more sustainable urban transport systems, rapid transit, and so on, for that reason.
John Francis from the UNESCO Scotland Committee. I'd like to ask both speakers, in view of the fact that they raised the question of financing this movement to a low-carbon economy, why they made no mention of the creation of a new United Kingdom Green Investment Bank. And indeed, I'd like to know whether they think that Scotland might be the appropriate home for this bank.
Thank you. And then down here. Thank you.
Hello, Maitland Mackey, the maker of the only carbon-positive ice cream, footprint ice cream in the world. Here we are. And that is counting the methane from my 500 cars. No, I'm sorry, Chairman, but 4 quick questions. They're quick, honest, he says. The first one is agriculture. You're giving us bad marks as farmers. You're quite right. But why don't you consider and trail us into minimal tillage, which soaks up carbon dioxide into the... We've tried it for 10 years. The reason we've had to stop is simply because the bureaucrats in wherever they are in Brussels have stopped the production of the only weed killers that can keep the grass weeds out. And there's something about getting the act together there, but that's the min tool. The second one is, isn't the feed-in tariff a dreadfully biased piece that's teaching or actually making people spend enormous amounts of money on tiny little outputs instead of focusing that money much better on bigger, better systems of production, of renewable energy production. The next one is, isn't your focus, we had a splendid lecture at George Watson's school the other day from the I'm having a 74-year-old moment. The chief executive of the Environment Centre the Climate Change Centre. I've lost his name for a second. But he made 3 points. There was an energy crisis, there's a food crisis, and there's an environment crisis. My submission is, if you all concentrated far more on the energy crisis of the world, you'll solve the end one, but you'll take us all down the road much faster of renewable energy if you focus on the energy crisis, is a question. And my last one is, is growth economics sustainable in future? Thank you.
Thank you.
Right. Yeah. I just agree with the point of view about urban cities. I think compact cities can be both environmentally sustainable and also economically and socially vibrant. Why didn't I mention the Green Investment Bank? Because in a lecture, you can only mention so many things. You can't mention everything you're in favour of. The Climate Change Committee is very strongly in favour of the Green Investment Bank. We've been actually, played a major role in encouraging government to have it and input to its design. I have no point of view on whether it should be in Scotland, because otherwise I'd offend one or other group of those either not in Scotland or in Scotland, so I'm going to avoid that. I'm afraid on minimum tillage, we have been looking at the details of agricultural techniques that can help. I'm not fully familiar with the details of minimum tillage. We did get, in fact, the Scottish Agricultural College to help us with detailed look at all the different technologies, and I'm sure it is in there somewhere in our specification of it. Is this one of the ones that reduces the nitrous oxide emissions? Is this the... Oh, is it carbon dioxide? Sorry. So it stops. Okay. Yeah. Okay. The feed-in tariff. I think we are. I think somewhat sympathetic to the idea that the residential feed-in tariff is a fairly expensive way of getting carbon emission reductions, particularly if you're putting solar PV on top of roofs. Solar PV, photovoltaics, will eventually, probably is the greatest technology in the end. I mean, let's be clear, most of our energy comes from the sun. Pretty much all apart from nuclear, which we derive from splitting atoms. Everything else is direct from the sun or derived from the sun. Fossil fuels are just stored solar energy. The long-term future for the end of the 21st century is to get it directly from the sun. And actually, there are signs that eventually solar PV might be cost-effective even in rather cloudy Britain. But right today, it is not logical to believe that the UK is the logical base to drive the development of solar PV. If solar PV goes down the cost curve, it will go down that cost curve because of its application in the US, in Australia, in sunny parts of the world, and we will just then pick it up when it is at a lower cost in the future. So there isn't really a good forcing the technology argument for the UK to invest heavily in solar PV. On the energy crisis, I'm a little bit careful if you mean by that the sort of peak oil arguments we're running out in any case. My main worry about fossil fuels in relation to climate change is not how few they are, but how many they are. I mean, basically, if I could arrange a group of aliens tomorrow to invade Earth and steal 3/4 of our coal, I would be almost completely certain that we will solve climate change at a very low cost because we'll be forced to it by the fact that we don't have the fossil fuels to burn. But my worry is there's so much damn coal out there. And although we are short of, we will probably have a peak oil, that'll probably go down, there's a hell of a lot of coal, there's a hell of a lot of gas, there's a hell of a lot of shale gas, and you can create liquids from gas and you can create liquid from fuel. Remember, the Germans were doing it as long ago as the Second World War. The South Africans did it. It's available at a cost. So I am wary of the argument that says we're running out of fossil fuels. On the whole, I'm worried about how much fossil fuels we've got, not how little, particularly because as we run out of some of the easier bits of it, which is non-shale gas, we end up doing some very environmentally disruptive stuff in the areas of shale gas. Growth. I don't think it matters whether the rate of growth of GDP per capita is 1.95% or 2%. And to the argument earlier, I do not believe that the evidence supports that that matters. On the other hand, I don't believe that in order to deal with climate change, we have to stop having growth. I actually happen to believe that growth should not be the objective, but is the highly likely result of other desirable things, such as a liberal economy and freedom of people to innovate. I simply ask you to read my forthcoming book on the subject.
Just 2 points. One on finance. The one thing that did emerge from our inquiry was the need for a predictable way of getting finance at the local, regional scale, and also having it tailored for renewables. The problem came that if you're looking for a return in 3 years, then it's not very easy to justify renewables. They have high upfront cost, but take a longer time to bring the full return. We were impressed by the examples of, say, the cooperative banks in Sweden, and the co-op bank here seems to be operating at that sort of level. But that was the one thing that does seem to be needed, a predictable thing. The land use, I haven't mentioned this time, but we do have a whole section on that and the value of changing land use management to try and improve the amount of carbon that can be retained in the soils and vegetation. And one of the remarkable figures to come out is that one can save money from farmers and sequester quite large amounts of carbon at a negative cost. I mean, you actually make money by doing it. Low-till was one of the ones that we mentioned in that regard, which where there are different views about how effective that is as a way of storing carbon in your soil.
Thank you very much. We're beginning to run short of time, but there's such a huge amount of interest. I'm going to take 2 more groups of 3. Could I just make a plea that you should speak briefly, and then I'm going to there, middle, and there, and then I'm going to go left over there, middle here, and then right at the back. And I'm sorry, sir, there's somebody with his hand out who I'm going to miss out on. If we go very, very quickly, we might do it.
Right, Ian Clement. I'm a local community councillor. Right. First of all, hi Bob, haven't seen you in years. Anyway, right. Certain things which I'm slightly concerned. I like the comments. First of all, this inquiry has not been independent. It's been biased. No scientists with opposing views have been on it. The other thing is what's concerning, there's been no mention of the UN report on climate change, which says that the individual must be subjugated to the world government. I find that very concerning. Also, no one has mentioned what is the ratio between anthropogenic CO2 to naturally produced CO2. Can we really change it? Solar warming. No one has mentioned about the solar warming taking place in our near solar system. The CO2 ice caps in Mars are melting. And negative feedback loops, like the CO2 carbonate, are completely omitted. Thank you.
Did you manage to get my other? Yes, thank you.
Philip Spark, just a visitor. Could I ask if you could expand on standby generation, how it's achieved, and what proportion of the wind farms are capable of generating electricity for more than half the time? Thank you.
Thank you. And I've forgotten who I said for the third now, but yes, I think it's the gentleman in there who had no, sir, behind you. It was the gentleman who's got a hand up just behind you.
Thank you very much indeed. Robert Hollingdale, I'm a chartered civil engineer with a particular interest in energy generation through nuclear and renewables. To Lord Turner, you spoke, sir, about the holy grail of energy storage, and your references to batteries was well taken. Would you like to comment on the possibility of using hydrogen as a future fuel source? I think there's a lot of potential there. To David Sugden, I'm very interested to note that your first recommendation in your report is that of proper management of the grid to accommodate renewables, in particular wind energy, given the fact that the constraint of payments that have been made between April and September this year is now amounting to some £7 million. Do you think that will provide an impetus to government to get on with that particular issue? Thank you.
Thank you very much. Let's start with you, Jean.
The comment at the start about the understanding of the past and climate, I think the question there is that we understand the past, and many of the things you mentioned can be explained. The problem is in dealing with a complex system, it's difficult to actually predict any complex system in advance because of the very nature of the complexity. And it's another example would be evolution. One can understand how evolution worked, but one can't predict how it would go in the future. So I don't think that's relevant. And you said, why didn't we have somebody opposing scientist on the board? I don't. Basically, we decided that the issue was risk, and whatever one felt about the science, the very sheer the nature and the size of the risk was such that it justified some actions by society in cutting carbon. Is Andy Kerr here? Is he able to answer that question? He's our energy person who could answer that one about the grid.
No, let's pass over to Adair.
Well, again, let me go in reverse order. Hydrogen, yes, an important energy storage device. Essentially, we ought to see hydrogen as an energy storage device rather than an energy source. And I think we are open-minded about its role relative to other categories of battery. Basically, if we have overnight electricity surplus to requirements, we can use that to charge a whole load of batteries, of people's batteries in their cars, or we can create hydrogen. And hydrogen may well have particular areas where it does have a clear role. In particular, let me give you an example within surface transport. Although we think it will be feasible to run cars off electricity through batteries, largely with certain range-extending techniques, etc., we think it's relatively unlikely that one can run HGVs on that, given simply the range that HGVs have to go and therefore the size of the battery. It may therefore be that the future for HGVs is on hydrogen-based engines, but we are certainly... No, there's fuel cells as well. I mean, but it can be either once you've got the storage device. I mean, the key to hydrogen is simply how much energy density you've got. It really doesn't matter whether you're then putting it through a hydrogen combustion engine or whether you're putting it through a fuel cell. So it's certainly one of the technologies which are there. We think it's slightly less likely than the battery-based cars to take off as a mass car thing, but we'd certainly be completely open-minded to it, and I think in relation to bus fleets it may have a major role to play, and maybe it will take off as a wider car technology. That does, of course, a little bit relate to the question about standby generation, etc., the whole issue of intermittency, that wind is generation is by nature intermittent. Sometimes the wind is blowing, sometimes the wind is not. That means that you need some sort of standby, and the logical standby at the moment is gas CCGT. That's probably the cheapest way of doing it. However, the need for that gas CCGT declines if you do two things. First of all, if you interconnect your continental grids, because the more that you interconnect your continental grids, the more that you are likely to have some natural balance between, you know, when Norwegian hydro has capacity to offset Scottish wind or solar in Spain offsetting this. The more that you interconnect the grid, the more that you will get a natural balance of these different activities. The other point is that the more that we head down a surface transport based on electric cars with batteries, the more that you have a natural storage mechanism, distributed storage mechanism, where people will tend to charge their batteries when the wind is blowing and not charge them when it isn't. Now, that depends upon some intelligent grids that can send price signals. I mean, what we need is a grid which is capable of telling people that the system at the moment is producing more electricity than you need. You know, plug your battery in now because you can get it cheap. And that's a very important part of the development. Finally, on the questions from over here, I think from a somewhat sceptical point of view. First of all, the easy one. The reason why, certainly, I don't know whether it was addressed to me, I didn't mention the UN report, which says that we need to subjugate the individual to world government, is I've never read it, and I don't agree with it. So that seems to me two good reasons not for quoting it. On the other points, the anthropogenic CO2 relative to natural CO2, I think, is a very poor argument. This argument basically goes, but look, the total amount of CO2 that human beings are putting out each year is very small compared with the natural carbon cycle which is going on. But that doesn't change the fact that if you change a relatively small bit, you change the system dynamics. If you have a bath, well, you have a swimming pool with 1,000 gallons into it, and into it is flowing, 150 gallons, and out of it is flowing 150 gallons, it will be in balance, and it will not be leaking and leaving, and those are in controlled pipes, in some sort of controlled cycle, then it won't be spilling out because there's 150 in and 150 going out. If you add 5, you'll start having 5 gallons going over the edge of the swimming pool. And it doesn't matter that the 5 is small relative to the 150. It has changed the balance. So this argument, I think, is a very poor argument in terms of the fundamental nature of a physical system and the need to understand its dynamics. So I really do think, I'm very well familiar with that argument. I think it's one of the skeptics' worst arguments, which doesn't take seriously the nature of complicated interconnected systems.
Can we take then the three very short questions, please? I don't know if those I selected remember who they are. That gentleman was one. I know there was one here somewhere. You, sir. And I think there's a lady back there, and that has to be it. I'm sorry, you tried before. Get somebody over drinks. Right.
I'm Ian Trail. I'm a former pupil of Professor Sugden about 40 years ago in Aberdeen. I'm interested that both the speakers impressed upon us that this problem is so critical, not just locally, nationally, but globally to the world that we live in, that we cannot continue without doing something about it. Both speakers also talked in terms of strategic planning at a high level, national, European, or whatever. What I would like to ask is whether the speakers think we have got things right by handing our generation of power and energy over to private companies, which not only extract a profit from the system, but also have generated such confusion by promoting thousands of different tariffs that it's generated a whole industry of computer, internet websites to sort that problem out for people, and generated mis-selling at the doorstep and over the phone. Have we really got it right?
Can you wrap up now, please, if you would?
Yes. Have we got it right by handing power and energy over to the private market?
Thank you. And then there was, it was here, I think. You've got a microphone, right?
Yes, my name's John Liddell. I have been installing fuel cells for the last 18 years in commercial applications, but I've been installing alternative energy systems for 40, I'm ashamed to tell you. Anyway, there were two quick things I wanted to say. One was that can we be mindful when we get immersed and enthused with new and emerging technologies to not forget the ones that we've had for years. I was project manager for an 88 megawatt tidal power turbine system that was installed in Canada in 1982. It's been running immaculately ever since. We tend to go off on the new stuff and forget the stuff we know about. The other thing that has concerned me for many years, and it seems to be achieving a bit of a balance, but it's this, we use the word biomass to cover much too big a subject. Biomass, when it's agricultural waste products, when it's short rotation, coppicing, that type of stuff is fine. When it comes to cutting down Canadian forests to ship it to Dundee to put in a biomass plant, I think is lunacy.
Thank you. And then the last question on the left.
My name is Tricia Henton. I'm a retired director of the Environment Agency, where part of my work was actually trying to ensure that we had effective and modern regulation to help drive forward some of these issues. I think both the Commission's report and the RSE report very clearly set out the issues and the problems, and in particular the barriers and the difficulties of getting coherence in regulation planning, and I won't go over all the points that were there, but they're all relevant. My personal view is, having been involved in these issues for about over 15 years or so, is that an awful lot of these issues, an awful lot of the problems have been well known now for a long time. And I'm not personally clear that we're actually making a terrific amount of progress. And I wonder if you'd like to comment that if in the last, say, 2 to 3 years, there has been a slowdown and indeed a lack of leadership in both politically and in the civil service, where some of these ideas are actually generated and taken forward. Do you feel that we've actually lost the impetus to really make progress now on this issue? Thank you.
First of all, can we do this with private electricity companies? Yes. I think there's nothing incompatible with profit-driven companies in electricity generation and the attainments of our targets, provided we have the correct regulation. The government is in the process of putting in place a new electricity market reform, which I think will be a much more coherent system of regulation, which will create better, more coherent incentives, and I am confident that that is doable and that we can achieve what we need with a privatized electricity industry, and I think there would be some disadvantages in changing away from that. On the need to look at old technologies, you mentioned tidal power. I assume you're talking about classic tidal range, like the one in La Rance in western France, etc. I mean, it is an absolutely proven technology. It's basically a hydroelectric scheme which goes off the tide coming in and out rather than a river or a dam. The issue is simply how much is the capacity for it, how much potential there is. And actually, the UK has one whacking great potential, which is the Severn River, and we've simply got to decide whether we want to do it. I mean, the UK could, on a completely mature technology, get about 4% of all its electricity from a Severn barrage. There are then arguments about the cost, and there are arguments about the environmental impact. Our point of view is that it is there available as an option if other options prove to be significantly more expensive. It's an interesting thing because it divides environmental groups, because it, as it were, has the climate change concerned versus the seabird lovers, debate goes on here. I think it is an acceptable way forward. I think there's a very careful report on it by the Sustainable Environment Agency for the government several years ago. So I think it's a possibility, but it's not transformational because it does depend on particularly estuarial conditions. On biomass, absolutely, totally agree with you that we are doing a major report now on biomass, and we are trying to be very specific about which categories of biomass you can think of as truly sustainable and which not. I mean, sadly, quite a lot of corn-based, maize-based ethanol in the US has simply replaced corn-based food production. It's done it with drenched in nitrogen fertilizers to grow the stuff in the first place, and the food production has been replaced elsewhere and has resulted in new forests or new peatlands or new soil being churned up. So we have to be very, very careful in the biomass and biofuel area to work out what is totally sustainable. On the coherence and planning, I think I'll leave that for Professor Sugden. But broadly speaking, I would say we are making faster progress on some specific technological challenges like fuel efficiency in cars than we are on some of the more complex social challenges like how do we create more sustainable urban environments which rely less on the use of the car. But I'll leave that for Professor Sugden to respond to that.
Yes, 2 points. The person who asked about private versus public companies, just as a point of interest, in our experience, it was the private commercial companies that had really taken the lead were investing on a huge scale. And that's mainly on electricity generation and issues like that. The grid, we certainly experienced the view that perhaps that was a problem, and to integrate the grid into the strategic planning, that was something that was proving difficult. Patricia mentioned the point about the old problems. Yes, but a point that Nick Stern made to us very powerfully was that this is all quite recent. If you go back to Glen Eagles, the meeting is, I think it was the 1980s or mid-1980s, that's the first time the top politicians were taking this on board. At the moment, you could argue that the climate change has sort of slipped out of the headlines a bit with the tsunami in Libya, and perhaps that's a very good thing. There's a lot going on in the background with private companies building and moving things on.
Thank you very much. Thank you very much for those answers. Thank you for those very interesting questions. I've allowed things to go on a very long time. It means you've got less time for reception and to drink, but I hope it was worth it, and I'll ask Professor Roger Croft to see if he would propose a vote of thanks.
Well, ladies and gentlemen, I take home 3 messages from our speakers. Firstly, how we deal with uncertainty. Secondly, this whole challenge about doing nothing. And thirdly, how we can stimulate behavioural change. I read a statement the other day, which I want to quote to you. Climate change is not a problem, nor are water shortages, erosion, desertification, species extinction, etc., etc. This wasn't written by climate change sceptics, I should say. They went on to argue that the issue was consumption and the effect that this has, the human footprint on the Earth that is now greater than the Earth's capacity. It was written by a very responsible group of people who call themselves the Global Footprint Network. The problem that I have, and I'm sure our speakers have with that sort of statement, is it's an oversimplification. It really gives a rather naive simplicity. It tries to park a whole bundle of issues and say the solution lies in this issue, in this instance, on consumption. As both of our speakers have made quite clear, it's essential that we understand what's certain and what's less certain, and that we understand the changes and try to have a greater understanding of the causes of those changes. The key elements of greenhouse gases, we do spend far too much time talking about carbon, and certainly not enough about methane, as came out in the discussion. We need to think more systematically and develop frameworks and translate those effects onto society and onto economy. We also need to have a greater understanding of interactions and feedbacks and thresholds. Otherwise, it's pretty clear that we'll fall into the trap of doing something, or indeed of doing nothing, based on unfounded evidence, or dogged ignorance, or just plain prejudice. Which leads, I think, to the second point, this challenge to do nothing as our efforts are meaningless. Lord Turner quoted the statistics about the very small proportion of global emissions coming from the UK and from Scotland. But it is a moral duty and an ethical responsibility that we both show leadership and take action. We didn't make mention in the talks or in the discussion of 2 quite seminal pieces of legislation, the UK Climate Change Act of 2008 and the Scottish one of 2009. They were quite groundbreaking, not just here, but globally, and that shows real leadership. But also we have had these 2 independent committees, and I would dispute what one commenter said, that they aren't independent. Having been myself involved in 2 RSE committees, I can tell you they're jolly independent of the high hegions of this society, and long may that continue. The UK Climate Change Committee, as we have heard from Lord Turner tonight, has given a very focused approach to its work. It uses scientifically informed basis. It's come up with a targeted and budgeted approach. And it's made quite clear what the requirements are. The need to increase energy efficiency. Everybody says that, but we're not making great inroads, and we keep having to bang away at that message. Changes in lifestyle and a low energy approach. And all at a very low social and economic cost, and we mustn't forget that. And the RSE Committee, which is very complementary, a wild consultative approach, targeted recommendations for action, especially by national and local government, and also a plea for regional approaches, which we rather lost from the 1980s in local government reform, and removing institutional blockages. And a key message from both is getting the message across to people. And the third point that I take home is what I call the irreducible minimum of double behavioural change. Of course, we have to increase our knowledge and understanding so that we can reduce uncertainty, so that we can calculate the probabilities, and so that we can develop decision rules. Of course, we have to model potential futures and their economic, social and environmental consequences. Of course, we have to use better existing technologies and develop new low environmental impact technologies. And we need to bear in mind that very significant point that Lord Turner made in one of his answers about the vast non-renewable resources we still have, and how we can persuade people not to use them, keep them in the ground. But all of this doesn't mean anything, including how we report on emissions and consumption and footprint, unless we change behaviour. We're stuck with NIMBY. Some of you clearly haven't heard of banana. It's a wonderful one. Remember it, because it goes right to the heart of the problem. First, we have to change our behaviour as consumers and reduce the impact of our lifestyles, not just at home, but on the globe, on the human and natural resources. But also, second, and this is a message that I always concerned about, is that we need to keep arguing for changes in the mindset of others, in our own decision-making fora, but internationally as well. Fred Pearce, who's a well-known writer on climate change issues, wrote in a recent publication of the Sibthorpe Trust, Climate Change Action, What Next? And you'll find copies of it outside, end of trailer, President, that we were now into this interminable diplomatic game for looking at a new Kyoto Protocol, etc. That is profoundly depressing. I have to be careful what I say, bearing in mind the President is a former diplomat, but I think he will know what I mean. It's the importance that we argue for change, and we use all of the information from the likes of these two reports. Otherwise, we will, as Matthew Glass prophesied in his recent novel, Ultimatum, have the spectrum of the presidents of China and the USA seeking solutions about the ultimate crisis point in 20 years' time. So thanks to Lord Turner and to Professor Sugden for their presentations, and through them, thanks to their committees for the very important work they're doing. Thanks to all of you for provoking debate, which I'm sure will go on afterwards. Reflect on all of these points, then I hope, as our speakers have suggested, that you will act to change your own behaviour and try and influence others to do the same. Thank you very much.